All right, so you should be doing the do now. So I hope you're doing that. Today is November 5th. And today we're talking about polynomial inequalities. So we've been solving polynomials and rational functions, solving and graphing. We're doing the same thing today and tomorrow, but today we're solving polynomial inequalities. Inequalities are the greater than, less than, greater than, equal to, less than, or equal to. And it's a related process to what we've been doing, but we have to ask a very different question. The only thing we can do mathematically, algebraically, is like this. We can find where a polynomial is equal to 0. So we can find the zeros. And of course, you all have a graphing calculator, so you could put these the polynomial in your calculator, and you might as well do that to graph it and take a look. And then we'll do the algebra as well, because this is an algebra class. It's 9x minus 9. So we can actually find where our polynomial is equal to 0, but today we want to know where it's greater than 0 or where it's less than 0. So we have to talk about what that means. And so you can see when you graph that, do you get a nice little squiggle? How would you do this by hand? How would you solve this? Factor by grouping, sure. So what's the GCF in front here? X squared, which leaves behind x plus 1, and then the GCF in the back. And we leaves behind x plus 1. And now they have the common factor of x plus 1, and it leaves behind x squared minus 9. Which we could double bubble or we could solve. So we get x equals negative 1. And here we would get x squared equals 9 and take a square root, and we get x equals plus or minus 3. So to graph that, then we could graph it, and we have negative 1 as a 0 where it's equal to 0. We have negative 3 where it's equal to 0, and we also have positive 3 where it's equal to 0. And then the graph, as you saw in your calculators, passes through those, much like this. We're going to do all the same things today. But today we're asking the question, what interval on the x-axis, where is our function positive and where is the function negative? So our function refers to the y values. So where do we get positive y values and where do we get negative y values? Well, positive y values occur where our function is above the axis. And negative values occur when our function is below the axis. Right here, forever, for all of these x values to the left, our function values are negative. And so we have to figure out how to write that. And everything is based on the x-axis, based on the independent variable. I love doing this kind of stuff. So really today we're asking, where is our function above the axis or where is it below? Where is it positive? Where is it negative? Okay. And so if you know how to graph the functions, and you can do that with your calculator, which is kind of nice, then this turns out to be pretty easy. So kind of fun. I love this stuff. I think it's totally cool. Let's do a few more. Example 1, solve the inequality. Graph the solution on the real number line. And write using interval notation. Write the solution using interval notation. So we're going to graph just like we did, and it's essentially you're graphing, we really only care about the x-axis, but you might as well just graph it like we just did on an xy coordinate plane. It means the same thing. And we want to know all the x solutions that give us the result we're looking for. Okay. So we have x squared minus x is greater than or equal to 6. And for all of these, the first thing we need to do is make sure that we're set equal to 0. Just like always, when we're solving higher order equations, we just want everything on one side. So I'm going to subtract 6. X squared minus x minus 6 is greater than or equal to 0. Now, this is the equation that we're trying to solve, but we can't actually do that. This is asking, where is our parabola? Where is parabola greater than or equal to 0? What does it mean to be greater than or equal to 0? Positive, yeah. Greater than or equal to 0 is positive. So we're looking for where our function is positive or above, maybe OV, above the x-axis. And we'll take positive, and we'll also take when it's equal to 0 as well. So we're looking for where our function is positive, and there's a couple of ways that we can do that. The first thing we want to do is what your book calls find the key points, which I think are stupid. Key points, the critical points is the critical points are what we're really looking for. Critical points is the language you'll hear. Critical points are the zeros and where something is undefined. ED, undefined. And so these are the critical points. And what's interesting in any graph, if you have a 0 or if you have something that's undefined, those are the only places where a function can change from all positive y values to negative values. Okay, those are the only places where it will occur, which is pretty interesting. And so those are why we call them critical points, because our values change from positive y values to negative y values at those places. Tomorrow we'll look at where things are undefined. So I'm going to go ahead, and our job is to actually find the zeros today. So I'm going to go ahead and factor this and actually find where it's equal to 0. Which is going to find our zeros for us. So we can factor this. X times x is x squared. What times what is negative 6? Negative 3 and positive 2. So we have zeros at x equals positive 3 and x equals negative 2. So I'm going to graph these on the real number line. Well, the real number line is just the x-axis. But I might as well, since I have a graphing calculator, you can use it. But here's negative 2. This is where my function is equal to 0. And here's positive 3, again, where my function is equal to 0. And this is a parabola. Is it an up parabola or a down parabola? It's an upward parabola. We know that because it's a positive x squared. So we know it looks something like this. And we don't have to go for a brilliant picture here. But we are looking for where our parabola is greater than or equal to 0. Which means, where is it? Where we have positive y values, everything up here are positive y values. And that occurs for everything to the right of 3. Positive land over here. All of these outputs are also positive above the axis, and that occurs for all of these x values that are less than negative 2. In between here is negative land, but here's what we want to know. We only care about x's, because that's the independent variable. So when we look here, all of these x's, all the way to where? Negative infinity. All the way to 2, and at 2, we're equal to 0, right? Are we interested in being equal to 0? Yes, we are. We want to know where we're equal to 0 as well. So I'm going to include that -2. And then over here as well, at 3, we are equal to 0. So I want to include that with the bracket. And then all those x values to the right produce positive outputs. And so our solution goes from -infinity to -2. And that's the U for union. 3 to positive infinity. Now, what does that mean? So, testing a point. You can always test values anytime you have an inequality. And so what this means is, in these two intervals between -infinity and -2, pick a number. Give me an x value between -infinity and -2. -4. Okay. So if x equals -4, then I'm going to go to my original and I'm going to test it. -4 quantity squared minus a -4 should be greater than or equal to 6. This is a true-false question. If it's true, we did it right. If it's false, we did it wrong. Okay? -4 quantity squared is 16. Minus a -4 becomes +4. Is 16 plus 4 greater than or equal to 6? Yes, it absolutely is true. What that means is anywhere in this region, we are going to produce outputs that are greater than 6. If you wanted to plug it in here, you could also do that, and it'd be a value greater than 0, greater than or equal to 0, okay? So you can always test points, and that's your first question on your homework, is just taking it and plugging it in and seeing if it works or not, okay? So same thing over here, letter B. We have -3x cubed plus 6x squared is less than -9x. So again, I'm going to move everything to one side. So I have -3x cubed plus 6x squared plus 9x is less than 0. And then what can we do to solve for the zeros? GCF, yeah, there's definitely a GCF here. I'm going to say a GCF of -3x. If I take out a -3x, what's left over? X squared minus 2x minus 3. Good. And then I can try and double bubble. So again, we're finding the zeros where it's equal to 0. I can't actually solve polynomial inequalities. It's not like a linear inequality. It just doesn't work the same. X times x is x squared. What times what is -3? -3 and 1. -3 and +1. There we go. And so we get, here we get x equals 0. Here we get x equals 3 and x equals -1. So again, I can make an easy sketch of this. 0, 1, 2, 3, and -1. And again, you have calculators. You can maybe do this on your calculator. Certainly on a test. I'd say you want to learn how to do it by hand. So this is a cubic with a negative in front. How do I draw that? Yeah, it starts up high, so it's going downhill overall. All right. Again, if you weren't sure, you could use your calculator. And on this one, we want to know, where is our polynomial less than 0? What does that mean to be less than 0? Negative. We're looking for, where is our polynomial negative, or where is it below the axis? And so I can see that pretty clearly. Right in this area, our polynomial is just under the axis. And also over here, our polynomial is under the axis. And so what is our x interval? So right here, this little space right here, these x values produce negative outputs. Should we use brackets or parentheses? Parentheses. Do we want to be equal to 0? No, just less than. So we actually aren't going to include those. So -1 to 0 union. And then everything over here, all these x values forever to infinity, also give us negative outputs. Again, do we want a bracket or parenthesis at 3? Parenthesis. Again, we don't want to include the 3 because 3 is where it's equal to 0, and we only want to be less than 0. So from 3 to infinity. Okay, questions on those two? All right, last one. They've done all the work for you on this one. I don't actually know that you have any like this on your homework today. I think I took them off, but I did want to do one just because I wanted to remind you of multiplicity, okay, and graphing. So this was a chance for me to review. They've already done the factoring for us. You can see we're already set equal, or not quite equal, rather, to 0. And so now we need to just find the zeros, which we can do by setting each bubble equal to 0. So we have x equals 0, multiplicity 1. Here we get x equals -3. What's the multiplicity here? 2, because of our power. And here we get x equals 1 with also a multiplicity of 2. What does it mean to have a multiplicity of 2? It bounces, yeah. The other thing I need to figure out is the leading term here. What power? X to what power if you were to multiply all this together? The 5th, yeah. X to the 1st, here this would give us x squared and another x squared. So we get x to the 5th. Is it a positive or negative x to the 5th? It'll be positive, yeah. All right, so we know it's an odd function and it's positive, which means it's going to start low and end up high. And I can make a quick sketch. And again, this is totally something you can plug into your calculator. I just like talking through this stuff because I think it's totally cool. But I'm a math teacher, so what do I know? All right, so at -3, we have a bounce. And I know I have to start low. So I'm going to come up to that -3 and bounce off of it. Bounce back down. Then I'm going to approach 0. 0, I get to pass through it. So I've got to turn around and pass through. And then I'm approaching 1, and it also has a bounce. And so I have to turn around and bounce off of the 1. So really interesting function. It's not the best drawn curve, but did I do something wrong? All right. Okay, so now that we have a nice little sketch here, what are we trying to figure out? Where it's negative. Where it's less than 0, we're looking for where it's negative, negative outputs. All of these y values are negative outputs. All of these between 3 and 0 are negative outputs as well. Everything over here are positive above the axis outputs. So this is kind of a tricky one. So what is our x interval? What x values produce those negative outputs? -∞ to -3. Oh, interesting. We have to stop. Why do we have to stop at -3? It's not negative, it's 0 at 3. So we don't want to include the 3. Good. And then what else? -3 to 0. Very good. And again, we're not including the -3 and the 0 because those are zeros, which are not negative. 0 is technically neutral. All right. Do you guys have any questions for me? Cool. That's fine. All right, y'all can start on